Hi, this is Naoto Hieda and Schweder, and today we come to you to talk about Empty Mind, and specifically about the technicalities behind Empty Mind. What is Empty Mind actually about? So basically what you see is you see a performer, Ine van Uveren, playing the flute, wearing a mocap suit. You can see that we have a dynamic, virtually moving camera, which was actually moved by Christoph Timmermann in real time. And we can see that the audience is able to interact with the performance by sending emoticons and also moving their mouses on screen. So one thing, just out of the gate to get that out of the way, like how did we get the motion capture data in real time into Unity? This was done via Rokoko Studio, and we used, for the performance, we used a Rokoko suit. Rokoko suit allows you to do motion capture without an extensive or expensive motion capture rig. Like, it has its benefits and it has its drawbacks, but for what we wanted to do, like basically capture the movement of the flute player, this was sufficient, and that was also what they had lying around, so we used it. Quickly, like the pros and the cons. The pros I already talked about. You don't need an extensive rig. The con is, for example, that it's quite hard for the system to keep its position in space. So sometimes what you get is that the avatar is drifting out of the way, or it's like losing its 0 point, and then you always have to recalibrate. That was why during the performance you would always see us going into the A pose again with Ine and always recalibrating, because you would always get the avatar drifting, and then if we would have kept going for the whole performance, in the end of the performance, Ine would have been virtually hundreds of meters away, probably. What Rokoko Studio looks like is basically this. You get an avatar that basically shows you what you get as motion capture data in, and then you can stream that already correctly rigged data into Unity and use within Unity this data to drive characters. We can jump into Unity now and start showing the technicalities behind what we were just talking about. The other data that we also collected was real-time audio data, which is based on a system that I created in another fellowship, and I used pure data for that. Unfortunately now, in this case, or in this scenario here, because we're running so many different like screen recordings at the same time, the system is going a little bit crazy. But this is what you can actually see. Like, I would be getting audio data in from a microphone, and then I would analyze that within pure data, and send the values off to Unity. This backbone is a backbone that is created by Chikashi Miyama and provided to me for the Sound Vision project I did a few years ago.
So basically, with these two components, we get data from Ine, the flute player, with her movements and her flute sound.
So last but not least, we had our virtual camera, which is actually seeing whatever you see in the game view also on the iPad, and would allow us in specific moments to actually move the camera around. So I'm going to demo that real quick here. So we basically had the option of have a handheld camera, because what I found out is basically creating a 45-minute performance is super hard work if you want to visualize everything. And especially like in the case of Empty Minds, we didn't have like a hybrid thing. So your eyes don't have anything to rest on other than the virtual presentation of whatever you see. In the very beginning of the performance, we actually show the real character Ine, like the video capture of Ine, in the mocap suit and the virtual avatar side by side in order to give the audience the information like this is real time. We are actually doing this live right now. But after that point, you never see Ine in person again until the very, very end. So basically, we have to create everything for these 45 minutes. Basically, writing a short movie, or like in this case, full movie in virtual space, or like creating that within Unity. And that is a lot of work if you want to make that interesting for 45 minutes, like visually interesting for 45 minutes. But a trick that we actually came up with was like having this handheld camera in there, because that actually allowed us to have Christoph walking around in virtual reality and always showing new perspectives, showing new angles of whatever was happening. So even if nothing much was changing, you could at least change the view of the camera and thereby keeping it interesting. And something else I noticed is just like if something looks handheld, your eyes immediately gets more drawn to it. Especially like if you see that this is whatever you have there must be virtually created. As soon as you have a handheld camera in there, it's like, oh, something interesting is going on here.
And in the performance, you always switch between the camera and the more like a static
exactly.
view with the timeline.
Yeah, exactly. So this is something that we come back to, but there's moments where we fly up like with a camera crane. So we basically give the virtual camera to the crane, and then the crane flies up. You can almost think of it like that. And then there's different modes or like different scenes that we can blend between. But we're going to talk about that a little later. Diving into the Unity setup. So the first thing in Unity that you would see in the hierarchy here is the timeline controller. That would basically control the timeline. The timeline holds all the information of the different scenes. Then you have the title screen, then you go into the next view, then you go into the next view and the next camera position. In the timeline, basically, we had different cue points. And what this does is you had these different cue points, and I could actually drive towards the different cue points. I will show that off in a minute. So you have this timeline here, and this whole timeline basically shows the whole performance. So all the scenes are in this timeline. So when I scroll through, you can see that the camera is sometimes driving out, driving in again. And just to show off how it would really work is I have these two buttons here which say Q next marker or Q previous marker. So it would basically go into play mode. It would go to this marker. So it would basically be here. The playhead would be here. And then you could go to Q next marker and it would drive to the next position. In this case, switching something on in the background that we're going to talk about later. Then you could switch to the next marker and would basically go to this anti-mine title screen. Can switch to the next marker and would blend over to this top view of the first scene.
Just to clarify, these scenes are like dramaturgy-wise different scenes, but in Unity it's a whole like single scene that holds every different parts of the performance.
Exactly. Yeah, it's a good point. So what I'm actually doing here right now is there's a different game objects that holds several game objects underneath. And I would always only show the scenes that I need to be active in that moment. And I would only always run the scripts that should be active. There is a very neat feature in Unity's timeline where you can actually say, like, only make this game object active. And by doing that, also all of the children would become active. For example, now here you see that Awakening 1 should be active, everything else is deactivated, so nothing is here is active. Then you see that only this game object is active. If I move my playhead to the next scene, which is actually without desires, then you see that this game object is becoming active, which holds the avatar, which holds the background, which holds the visuals, and the whole how it would actually interact. That is all held in this one game object, and you can activate and deactivate it like that. Which is a very helpful system because actually everything is in one big, massive scene, but I'm only drawing and activating whatever I need for a specific scene. During the performance, I could just say, like, okay, go to the next blend to the next cue point. And if the virtual camera is active, I could actually then like take over from the static view and go into this view where Christoph would actually drive the camera by going around with the iPad. And if I hit Q next again, for example, something might happen with the background. So for example, like these hills might come up. And then there would be another cue in the end where the camera is going up again. And we would go again to a menu overlay. And then quickly, while just showing this, I can also talk about why I chose to make like this overlay into a whole different system. So what I'm actually doing is I'm rendering the menu scene on a parallel camera in Unity. So I'm blending between static cameras and handheld cameras. You can see that on top here, where I can zoom in a little bit, you can see that I have this main Cinemachine camera script that handles the camera motion. So when I'm here, I'm totally like only in handheld mode. And when I have this fade over, you see that it's actually blending to this top shot where I don't have any control over the camera. So I have a fixed camera shot. And then it would blend over to the menu, which is a completely different camera because I always wanted this blend over. And I also wanted to be able to load a different scene in the background, which is important because the audience is able to choose the next musical part. So what they would basically be able to do is move their mouse onto one of these objects, and then you would have a heat map of all the users, and we could ask them, like, what is the next thing that you want to see? What is the most interesting object that you see here? And then the people would be able to dynamically choose whatever they want. And what I would then do in the timeline controller, I would, for example, say, okay, they chose the scene ecstasy, and I can then just choose ecstasy. And what would happen is it would jump in the timeline, it would jump to the ecstasy cue point. There is an ecstasy cue point somewhere here, multiple choice, but the menu moments would always look the same. So when I go into the menu moment, let me quickly go speed the process up for a second. So when I'm in the menu again, I have three options left here, and these are also part of this whole storyline. Maybe we already saw this, but now we want to jump here, or we are here now, but maybe we want to see this scene. Only in the menu would you be able to switch dynamically to a different scene. So not from everywhere to everywhere, but only in the menu. Like this view would always be the same all on these moments, and then you could just switch to a different scene. For example, we could say now without desires, like chronologically without desires would be here. So when I click without desires now, we would basically jump to here, and that would be the same view, and then we would blend into without desires. Is that clear, or is that still a little bit confusing? Like, it was very confusing to myself.
Yeah, I guess after a certain point, we have the multiple choice where the performance branches out.
Exactly.
But the timeline feature in Unity is a linear timeline, so you have to hack into this so that you can jump from one place to another, but still keeps the what are the remaining options so that you will end the performance at some point.
Exactly.
It's like going back and forth, but then any choice you make, it will end up with the same cue at the end.
Yeah, exactly. So you can basically think of this as our light desk. So I could say for the first cue, I want the lights down, I want the waves down. In the second cue, I want the values for the waves coming up. I could, for example, show this, I think, in maybe in this very first cue where we come from the top down. So there's a couple of things happening at the same time. So when I now go to cue next marker, what would happen is we would blend to this handheld camera. Really quickly hold that camera so I can talk about what I want to talk about. And you have to, I think, oh, it's fine. Cool. Yeah. So what we would have is this blend between these two camera moments, and then there is a whole animation going on here in the background in this little animation clip. And if I open this up, you can see that if I switch that to curves, you can see that for the next cue, if I go to the next cue point, which is this at 15 seconds, it would actually blend in the waves. So this is the, I would send values to the shader graph to say like add a little bit of noise onto the world, and then you would basically get these waves. By the way, because we did not activate this right now, impure data, I would now get flute information or like audio information, and these waves would actually move according to the sound, but we just would change the height depending on the timeline position basically. And if we move on, then the camera is going up, and there's a couple of other things going on that are specific to the perspective and the mouse interaction of the users. Next thing, the avatars. Right now, what you see when I jump back into the timeline or I jump back into one of the specific moments, what you see here is dynamically generated avatars. On one hand, we get the data in from the Rokoko Studio, but on the other hand, like these avatars don't really work like normal avatars. Usually what you would have is you would have an avatar that is, basically you create that in Blender, and then it has a fixed shape, and you just morph the shape around to make it look like it's a human. These avatars work a little differently, and I can show this basically in this scene. So I'm going to scene view now, and what you see here is, let me try to explain what's going on here. So what we get, if you remember from Rokoko Studio, we get an avatar that basically looks like this. And what Unity allows us is to use every vertex on this avatar. So every point of the avatar shape of the avatar, not even the bones, like actually the model. So we actually have the model, not only the bones. We can basically use these vertex positions and draw that with VFX-Graph, or like use these points as starting points for VFX-Graph. So let me quickly show this off. Because what is actually going on in the background is I'm not drawing the main avatar that we get. I'm basically hiding the main avatar, so you don't see the vertices anymore. I just show the VFX-Graph output here. And to do that, you get two scripts in Unity. Basically, one is you get a binder script, which is called like skinned mesh renderer. And if I try to find where it's actually pointing. So basically, you have like the Rokoko input, and this is the avatar that I'm choosing not to draw. And I think I can even put a material on it. Then you can actually see what is going on. So this there you see like basically a hip bone. If I draw the whole thing, maybe 25 or something. Yeah, if I draw the whole thing, this is the avatar that I'm actually spawning the particles off of. You have the 3D model, and I just take the vertex points and feed that into VFX-Graph. So the next step is I just choose to not draw this pink avatar or this vertex avatar anymore, but I draw it completely differently. And if I go into awakening, like into my awakening scene that is currently active, and I show the lines avatar, this is actually what the VFX-Graph for that avatar looks like. So you can see VFX-Graph basically is like a massive particle handling tool that does a lot of compute shading for you in the background, and you can do a lot of cool visual effects with it, but it has its own way of thinking about programming and about data. Basically, it has a compute shader way of thinking about data. What you get in here is a texture that holds information. One is the position of each vertex that you choose to draw, and one is the velocity of each. vertex that you choose to draw. This is something that we get from this skinned mesh renderer script that Unity provides. If I, for example, say I want to output cube, what you would see now is I could draw on each position of the vertices, I could draw a different object. I could even set the scale here. So I could maybe make that a little smaller so you don't see it right here. So what I'm doing is I'm changing the scale, the X and Y and Z scale of these two objects. So you see that this is how many vertices I'm getting into the VFX-Graph. But then I'm choosing not to draw these outputs actually. I'm only using those positions as spawn points for even more particles. So you see from every point I'm drawing, like this is basically a spawning point for different particles. And this thinking basically is how the main avatars in Empty Minds were created. Oh, I messed that one up. Just let me fix this one. Let me unbreak it. I'll probably do this fine. Okay. If I go into play mode again, it starts drawing. It starts painting these boxes again. So for example, this avatar has the thing where each vertex spawns other particles, and you, as you see, VFX-Graph can handle like an immense high density of particles, so you can really make like visuals that don't even look like singular particles anymore. It more looks like a wave of stuff that is going on there. But for example, the beginning and the end avatars are done a little bit different. For example, here you can see that there is a dynamically generated avatar. This is still not a fixed model. You can see that if vertices are closer to each other, they actually connect with lines. You can see it here in the head and under the arms. You can see it a little bit between the legs also. Like you will see that the closer the legs come, the more connections you get. Still another avatar. We could talk, for example, about the menu avatar. Talking about the menu avatar, this is the most basic one. So you see that it is spawning points and then moving them around according to their vertex positions. If we go to the scene without desires, you can see that we were also in like researching and talking a lot about different ways of displaying movement. So what I did here is I basically took the vertex positions and drew them, but I added a lot of noise. So when you had a little bit of movement, maybe of one finger, you would get a lot of movement in this avatar. So what you would see here is that there's still actually, at some point in there is actually an avatar in there, and you'd see that the motion of the avatar has something to do with the motion of these spheres. So when Ina would be moving her arm, for example, some part of this cloud of points would actually move around. Yet a different avatar we were investigating was the one where you would only see something if the person wearing the motion capture suit was actually moving. So when Ina would be standing very still, you couldn't see it. So I would be using the velocity data that I get from the vertices. I would draw that into color. So you can only see the avatar if it's actually moving around.
And that's mapped to the body parts. So
Exactly.
if she's moving arm, then only the arm will.
Exactly. So that is why in this case, for example, you'd see mostly the head and the arms, but the feet not so much, because she wouldn't move the feet so much. And in the next scene, you see that the lights are coming on a little bit in the scene for the next queue part, and it's going more brighter and brighter, and then it's bugging out because there's the menu overlay. This avatar again is a little bit different. This is the avatar that we actually created in collaboration with Studio Plankton, which is the standard way of creating an avatar, and the mostly standard way of creating an avatar. basically you see here that we actually draw the vertices. So we have like these stone objects that are attached to different bones and that then move around when the avatar is moving around. So this was the most generally, or like how you would usually be drawing an avatar within
like
a
theeir
game.
chat or
Exactly, or whenever you have like a body representation in a game, you would see it basically drawn like this or similar to this. So the only thing different here is that we chose to not morph the objects depending on the skeleton positions. We just chose to only drive the transforms and the rotations, not the morphing, because we wanted this fixed stone style or this ice style, basically. Then there's something going on again, like the light mood is changing. And this was another one that we also created in close collaboration with Studio Plankton, which is like a very abstract avatar as well, where the idea was you have the different body parts represented by these cubes or rectangles, and those rectangles would also rotate by themselves. So you can see that this rectangle down here has a rotation, but it's also generally driven around by the motion capture suit. So you have both on top, and then you have the nice lighting. So the design came from Studio Plankton, and I just implemented it in Unity and recreating the shaders that would work in real time. The last scene is also quite interesting, where you had basically the avatars from the very first beginning moment, but if Ina would move closer together, and you can see that also when you're watching the performance, when all these avatars are coming closer together, they are finally merging, like everything is coming together and merging into one avatar, and then for the very final cue, the other avatars would basically dissolve, and you would only be left again with, instead of 4 avatars, you would be left with like 1 avatar in the end. So you had this lonely avatar coming through in the end. A big part of this whole performance was that people could actually see what's going on. And we have a reason why we only streamed video data to the people, not like this whole scene, or we wouldn't send them an app that they could install and then run, and then they would see it, or they could wear like a virtual helmet. And the reason for that, the thinking was, not everybody has a gaming PC. And if you want to democratize digital art, or if you want to make digital art also accessible so people can actually watch your piece, you have to take that into consideration. Basically, you have to think about how will my audience watch my performance, and just keep that in mind. So that was why in the very beginning of the project, we still were thinking about like creating a WebGL environment, or creating something like Mozilla Hubs where people could walk around themselves and watch the performer. But my idea was that I would rather go for higher tier visuals like this, and render it on one machine and stream it out to the people, and use a different input from the people, which then ended up being the whole Empty Mind experience. For streaming, we basically used OBS. So what we would just be using is OBS like this. And I would just stream the output of the game view. So right now the camera is in a weird position, so I'm showing the scene view. But this is what we would stream out to the Twitch stream, basically. Why did we choose Twitch?
So Twitch is mostly used for the gaming streaming, and the reason why we used it was it has low latency and it's quite stable. Any other reasons?
Also the quality. We looked at different other options, like especially like Vimeo. We actually wanted to do it on Vimeo, but the problem was that the payment model is so that you would have to have like a yearly account, and that you then whatever, like if to get a decent quality on Vimeo, you actually would have to pay a lot of money. So what we did was we basically hacked Twitch a little bit into our system. So we basically let Twitch run in the background, and Naoto is probably showing a little bit more later on how we did that. We could have opted for actually using Twitch itself because it has quite a nice API where you can track mouse positions and stuff like that.
Right.
But we specifically chose not to do that because we wanted our own website where people could enter the experience, and we didn't want them to be distracted by the rest of whatever is going on Twitch right now.
Yeah, so Twitch, like as Max said, there's option to use Twitch extension, but that's bound to the Twitch platform. Like you have to go to twitch.tv and then come to the Empty Mind channel. But instead, we use the embedded player on our website, basically. So it's just the iframe that shows in the background. So we have some constraints. For example, we cannot use the full API from Twitch, and obviously this is like if you do web development, probably you know, but you cannot modify images from the iframe. So we can overlay contents on top of it, which we did with emoticons, like icons, and also the cursor of your mouse movement. But it's quite limited with what we can do. Like you get the streaming from Unity, it's shown there as Twitch embedded player. Now I'm going to give you a quick overview of the web front end. And basically, as an audience, you would join online, and you get, if you register, you get the URL to the page that is shown here, and you would see quick to enter button if it's before the performance is starting. And at this point, I guess if you go to the same URL, you will see, you won't see the button, but instead you would see embedded video player of the previous presentation or the documentation of the performance. And the performance, this is a fake date, but last time we had performance that was in the time zone in Korea. So it was starting at 11 a.m. in European time. So there was a little bit of problem how to manage this time zone issue. But fortunately, we store this, the whole metadata, for example, the performance starting date and time, and also Twitch embed URL, these information in Firebase. And in Firebase, you can select what type of data you want to store. It can be string, it can be number, and one of the field you can select is the date and time. So what we did is basically just say it's starting at 11 a.m. in Europe, but then if you load the data on your browser, so I join from here, or you can join from Korea, the US, wherever you want, you would see the date in your local time zone, and everyone would see this click to enter button at the same time, because the performance is actually happening in real life and it's streamed. So it's problematic if we see it at 11 a.m. and in Korea, 11 a.m. in Korea, if they see it, then nothing is happening. So
it was like in Korea, it was like, if in Europe, for us, the starting time was around 11 o'clock, and in Korea, it was like 7 o'clock or something.
7 p.m., yes.
Yeah.
Yes. So that's a little bit of a detail. And okay, so right now we opened the page so we can enter. Click to enter, where it basically shows the embed player of Twitch.
Can you quickly say like why you are doing this black overlay? Like why you're showing the connecting and not like you the thing is like there's actually something going on in the background that Naoto is trying to hide.
Yeah, because this is Twitch embedded player, and actually there's a little info button, and there's a simple player that shows up here, which is just showing Twitch embedded player. And here you can see these little information from Twitch, and we want to hide it, so we just overlaid blank screen on top of it.
Yeah, and while loading, I think you actually in this moment where Naoto is making it black, it actually shows like now starting Twitch stream or something. So we just wanted to hide that in the background, so you're never really aware that you're watching on Twitch.
Yes, and this is because of web development, security issues. On the front end, it's just a iframe embedded player, so you cannot modify the content, what's drawn from the streaming. So the only way we can hide it is just to put another layer on top of it, which is just a black div, square div.
It's like a countdown. I think you give it like 2 seconds because we know that the Twitch logo is there for like 2 seconds, and then the stream starts.
Yeah, and also that kind of we kind of try to prevent people from reloading many times. That we'll explain later. Maybe I enlarge it so we can see the buttons bigger. And basically, there are a few UI components overlaid on top of the streaming, and one is this trail. So this is visible only for you. Like what you're doing is not shown for the other people. Besides that, you see this white
trail.
Oh, okay, so it's reloaded. But basically, now you see this white circle that's following the trail like a few seconds later, and that is rendered in Unity. It's kind of that's rendered in Unity, so it has delay because of the streaming. So there are like two things that are actually coming from the same information, but from different layers. One is what only you would see, this trail, and the white circle, the blob, is seen to everyone who's watching the performance. And that's one thing. And also we have these emoticons at the bottom, which are another UI component. And if you click on it, it will shoot an emoji inside Unity. So again, there's a delay because this is shown to everyone, not just you. So if someone's pressing these buttons, you would see it, and that's rendered in Unity, and that's coming with the delay. And here's the problem, that we always have delay, so that's why the trail is shown there to match the delay of what's coming from Unity. So if there's no delay, I would probably forget that I moved like this, but since there's a trail, you can see that, okay, it's actually this white ball is actually following my movement. And then also for these emoticons, when you press, it will shrink, and then it comes back and moves a little bit, which there's a little bit of a time lag, but this is another way for us to remind the viewers that, okay, I pressed, and then that's triggering the effect inside the streaming from the Unity. All right, so this is what we're seeing right now is a debug view, but you would normally see only this video part, the streaming part. As an audience, if you log in, you will see this part. And depending on the scene, right now it's just showing the pure streaming from Twitch. And you can still see that this white circle is moving. It looks a little bit random, but actually it's following my mouse. And the delay is just because of the streaming latency from our computer to Twitch to the browser.
Yeah. So basically, if you wanna think about it, it's basically every computer, every visitor is sending their mouse position to Firebase. Firebase is updating the mouse positions in Unity. Unity is being streamed via OBS to Twitch, and that has a long delay, like 5 to 20 seconds, depending on where you're watching, depending on what you're internet connection is like. So this is why you see this delay.
So this is a bit unintuitive for people to associate with their movement of the cursor. So that's why we added another layer on top of the streaming, because we cannot modify the image of the streaming on the browser because of security reasons. But still we can add layers to overwrite on top of the streaming. And that's one thing we did, is this trail. And as you can see, the trail remains there until the blob, the circle from the streaming catches up with where you are. And that's a way to make the association with your movement of the cursor to what's happening in the 3D view of the streaming. And also it's important to note that this trail is only visible for yourself, but what's happening on the browser, and other people watching the same streaming would see this white circle, they would see it, but they would not see the trail. They only see their trail.
Can you quickly simulate some of the users? Because we
Yes.
just added a function where we can simulate some users for debugging purposes, but it's also quite interesting to actually see what's going on.
Yes. So for example, if we have 5 other users, then you will see these dots that are moving by themselves. That's independent from your blob. So that's other audience. Right now it's a simulation, but when there are like, let's say 5 other people, you would see these dots, circles moving around. But then they will not leave the trace like you would do. And the other feature, I would delete the trail for now. The other thing that you would see on the interface are these emoticons. And this you can press, and it will shoot, in this case, rows in the Unity scene, but because of the delay, you just saw it now on the streaming. And this is also, just like we did with the trail, we wanted to make the association of your button, the emoticon press, and what's happening in Unity. So we made these little icons to animate with a bit of delay to compensate. And that ideally, with the movement, you will see the 3D model shooting in the streaming.
And then interesting side note is that this delay is not always fixed, right? So the delay of the latency of the stream is not fixed, and it's not even fixed for every single user.
Right. So this was a problem because every time, like because of your internet connection, like where you are, or our internet connection from Unity, there's a bit of offset. I mean, difference in offset or the latency. So it's hard to say that it's always 3 seconds or 5 seconds. And we did some research how to compensate this variable latency, and we found out that in Twitch extension there's a value called HLS latency broadcaster that is documented in their Twitch API. And actually, if you dig into the API of the Twitch embedded viewer like we're using, there's also same value that you can get, and it's quite reliable. So that's what we do. So let's say this value, we're constantly checking, and if it's 7 seconds, then it will make the animation after 7 seconds after you press the icon. And there's also actually this another detail, but I think I added like the latency plus 2 seconds or 3 seconds, because there's another latency that comes from your streaming. That I think the value you get is the difference from Twitch server to your browser, and there's another delay that comes from your OBS, the Unity OBS streaming to Twitch. So we had to like manually adjust these values, but for now we got quite pleasant result, as you see here. Well, sort of.
So this is dynamically changing all the time, and it also it means because we're using a European Twitch server. I think could we even fix it? I think we even fixed it to a Frankfurt server because that was the closest server, or something Amsterdam. I don't know. But like if people would be joining from Korea, for example, like last week, they probably had a little bit more delay. But this would always dynamically change. And interestingly, also the longer you are in the performance, the longer your delay gets. This was something that we couldn't avoid. It's something about like how this whole Twitch and how streaming works in general. But I think like what's happening right now.
Yeah, for example, what is happening now is with the buffering, and that will add it will accumulate delay. I think there's a bit of a logic to catch up somehow, but it works sometimes not. So it's a good way to look up this latency value from the API and use that as a variable latency.
And did you even like restart the stream if the latency would be too big? I think we had that somewhere in there.
Yeah,
but,
I think we tried when the latency is too big, it will refresh the viewer, but I don't remember if we use it in the production.
I think we threw it out because we noticed that sometimes people have like super slow internet connections, and we just didn't want to force them to always reload. Yeah.
And now so we saw that the interaction is happening from the browser to the Unity stream, and you would see it back in the viewer. And how does this happen? Basically, we have this Firebase and Firestore from Google that you can use it as a database, and it's quite it happens real time. So all these mouse movements are recorded here. So as I move the mouse, you see these values changing in real time, and that's broadcasted to the Unity program and also to the other browsers. So everyone gets where other mouse cursors are, and also Unity gets that information. So everyone's on the same page during the performance. So these mouse movements are actually. Is there a way to show the Unity project at the same time? Okay. So here we have the Unity window and the browser side by side. And as you can see, if I move the mouse, it appears quite instantly on Unity because that's broadcasted through Firebase. So this is Firebase, and as I move the mouse, these two values here, normalized X, normalized Y, they would update. But on the browser, there's a huge delay because there's always delay from Twitch server to what we see on the browser. And when we see this side by side, you can see that Unity is updating quite instantly to this mouse movement.
With slight smoothing, yeah.
Yes, there's I think the frame rate of sending out the mouse movement is around 10 times per second. So instead of 60 frames or something. So because it's still quite fast, but not visually, it's not fast enough. So there's smoothing that compensates the frames between them. And also, if there are more users, you will get more latency from Firebase. So it's important to have this smoothing within Unity Heatmap. And as you can see, I move the mouse. In Unity, you see it instantly, and then it's sent to the Twitch server, and it comes back from Twitch server to the browser, so that's why there's a delay. As a recap, when I move the mouse, that updates these XY values on Firebase, and that's sent to this Unity here, and then that's streamed to from OBS to Twitch. And what you see on this browser is, so it's connected from your mouse movement, but goes like all the way from Firebase to Unity to Twitch and comes back to the embedded viewer.
So you have quite a long round trip. Could you show off the how long it takes to throw an emoticon? So
yes. So when I click it, you will see it instantly in Unity, because to Firebase to Unity is quite fast. But then there's another few seconds of delay from Twitch to the embedded viewer. So you see it actually taking more time. Yes, you see it now. And again, these emoticons are rendered on Unity, so it's not just that you're seeing your button press, but if someone else presses these buttons, you will see it in the embedded viewer as well.
yeah. So the reason why we chose to actually draw the emoticons in Unity was that we also, in some moments or in some scenes, the emoticons are actually reacting visually and also like physically, or like simulated physically with the environment. So objects would bounce off the floor, like in this scene, for example. And we could have also done that in the UI,
but it's very hard to match the aesthetics.
Exactly. So we wanted that to draw that in Unity. So that is the reason why we made all this hassle.
And one last important thing about this front end is that it's also getting data from not just the what's rendered from Unity, but also Unity is sending information to Firebase to the browser. So for example, if I move the timeline in Unity, you would see that, for example, in this scene, you would only see this heart in the player.
And you can also only press the heart.
Okay, now you see with the delay, and then soon you will see heart shooting.
If the camera is in the right position, let me get the virtual camera in the correct orientation, then you should also really see the heart. And I think you need to go to the correct Q. So now this should work. So throw a heart again. Oh, there was a heart. There's a heart.
Oh, yeah.
Like it's not really visible in this whole mess. So I will move out, and then maybe you can throw another heart.
Oh, I don't have it anymore. But I can go to another scene.
Yeah.
And oops.
Yeah.
So these scene queues that happens in this Unity timeline is also sent to Firebase. And again, Firebase is not just a database, but it's broadcasting all the data to whatever client, if it's Unity or if it's browser JavaScript. So it's not just one way from the browser mouse information to Unity, but also it's bidirectional. And what's happening in Unity is sent to the browser. So now I only have this fire emoticon, and if I press it, then you see it inside Unity on the right hand side, and that will be streamed back to the player now.
And it's also like physically then interacting with the floor again, like visually interacting.
This is normal view for the audience, and you have these buttons. Right now I don't have the trail, but you could see the blob moving towards your cursor. And this whole thing, web development, was done with React JavaScript framework, and was very useful for separating components like these emoticons, and they all have tied to this specific table inside Firebase. So they're quite modular. It's easy to add another emoticon or add another queue. Yeah, that's how it's built. Yeah, I don't know what else.
Okay. Just like to cap it off, a lot of the things that Naoto also had to deal with, obviously, is like these whole scaling issue things. So we try to make sure that it's actually running on mobile as well, which is in itself a terrible thing to achieve. But it worked out, like I think in the end, and it's especially for like live presentations, it's quite interesting that people can sit in the audience and play with their phones. Yeah, but this actually worked. So people could click with their fingers and do something there. So that would scale, and that was actually a huge task to also be solved by Naoto. And let me quickly now show the implementation within Unity. So a quick recap, what we see right now is down here, we get the browser view with the stream and the delay and the whole interaction, and it's all scaled and scalable. And here we have the Unity view. And what would actually happen is that we sometimes want different emoticons appear. So we didn't want to always go and give all the emoticons to the people. What we wanted to give them an option in certain scenes to throw only certain icons. And the way Naoto implemented that is by having game objects relate to these emoticon spawners. And these look like this. You have game objects, and on that game objects there's a script that is actually only sending to that one variable. You're updating that one variable, and we could change that here. And basically the emoticon would only show up if that game object was active. So as an example, now you would see that only the star is active, and you would see that we have like an active block in the timeline where we activate this game object, but all the other game objects were deactivated. Then in the menu, it's annoying. In the menu, you could see all the objects, all the other objects. I'll quickly pull it a little bit down, so if I switch, you will still see it. So if we go on a little bit, then you see that all the other objects deactivate, and it will only show the one active game object, which is corresponding basically to the active game objects up here. And then one very important thing that we found out after the first performance, I think that was something that you implemented like within the last 10 minutes of the first performance. No, in the last 10 minutes before the first performance, that feature was ready, which was this this counter down here. So we actually made sure that people were not able to throw more than a couple of emoticons. Like we can show this in the menu. In the beginning, like in the first tryout, we actually had
unlimited.
No, it was not unlimited. I think it was like 10 emoticons. So you could each emoticon you could throw 10 times. So this number would be 10. But what would happen was that people would spam these buttons, and if you have 50 people watching and everybody's spamming each emoticon for 10 times, you can imagine, I think I can even show like a little screenshot of what happened, was that the whole screen would just be full with emoticons. So we dialed that back actually. So we gave the people a lower number of possible thrown emoticons until those emoticons get respawned. So for example here, if the game object becomes active again, you get a new amount of emoticons, which was fun. And then also in the menu, which is quite interesting to see, how did we actually achieve like this perspective shift? Because what you're seeing right here is basically the camera is looking perspectively, not like top down, but from the side. And what's actually happening in Unity is quite interesting, I think, because what I'm doing, I'm drawing all the mouse positions to a heat map, basically. And if I just show this heat map, this is what the heat map actually looks like. This is the data that we actually used, and we did actually a second version for the last performance. We had a little bit of feedback stuff in there. We put that all out. We made that. Basically, it is what is it called? Not Metaball. It's a Metaball system. So if you have more than one user on one spot, basically it adds up and becomes the spot itself becomes a little bigger. So if Naoto is now joining with his phone, you can see that when we come close together, basically we build like this little blob. And this texture, this black and red texture, is what I would use in the different scenarios. For example, in the menu, I would then use this as an input for a shader that I would use to displace the cubes here. So basically, when you go here and I put my mouse here, there will be like a little mountain where I have my mouse, and if there is more than one person there, then they could also make that mountain even bigger or greater. And that was the whole thinking about like getting position data from the mouses and making choices by these positions. Interesting also, I don't know if it works, like if we are all in the top left corner, I'm also switching the light in this specific scene, for example. So I'm calculating like where are most of the people. Depending on most of the people, the more people are in one spot in percentage, the more I switch on that light over there. And because we are just two people at the same in the same room now, it's going 50%, between 50% and 100%. So if Naoto is going to the top left corner, you see that the light is coming on by 50%. And if I'm also going there, it's going on by 100%. So this is like a lot of these things we did. And also one thing, like we tried to do that smartly, dynamically, but in the end I switched to a manual move where this value here basically is the radius for each user. Because what you have to imagine is that if for example we have 100 users in the performance or 100 visitors in the performance, we would basically want their scale to be a little bit smaller. Right now we have this size, but imagine you had like 100 users, we would make the size a little smaller. But there were so many little things that we had to think about. Like for example, if you think about the mobile version of the performance, then the idea would be that this is not a mouse anymore, so you would always need to save the last position of the finger press. Like little things like that kept us developing and developing. So even if you would let go of the interface, I think it would still remain at your last known position, right? Or would you actually no, it would stay at the last known position?
Yeah, but I think that, so for mobile, I think it's quite similar. It's just in JavaScript you have mouse parameter and also touch parameter, and I think for this I'm just getting the first touch movement. So if you have two fingers,
Or you're getting the middle.
Oh, interesting. Yeah.
But that is something that the interface does for you already. That's nice.
Yeah. So it's kind of like interchangeable, and there wasn't that much of problem with mobile, except that you have to work with CSS to make it display nice on the small devices.
And then quickly overview of the possible interactions in the different scenes. It wasn't really easy because we always had this perspective shift. So the problem was always we were projecting 2D positions from the screen into the 3D world, and this was the thing that I would always have to deal with, like visually, what do you do? There's a couple of things happening in the first scene. Like we started off building or developing this very first scene. I spent a lot of time on this very first scene. And it visually makes sense from the top view most. So when you come to a position, you see that you are displacing the environment a little bit, as well as the avatar. So the avatar is always making a little mountain, and your mouse is always making a little mountain. But if you queue to the next camera view and you go down here, you fly up with the... For example, a camera view. If you are in this camera perspective, then it would change. And it would always depend on the camera position as well. So where you would point the camera would have to mean where the displacement would be in the environment. And that was something I think we could have spent more time on, but we ran out of time. And this is also why in this scene specifically, you would not see Christoph run around with the camera like Naoto is doing right now, but he would do actual super slow movements and try to do quick motions in between and then take another stationary shot. So this glaring problem wouldn't come up so much. And there you see still some visual bugs in there. So you see a little bit that I'm creating actually two mountains here. So one mountain here and one mountain in the back. And this is something that I just had to deal with. Like after a while, I had to stop and work on the other scenes. A different example, for example, in this scene, you can see that our interaction is doing something like something blobby as well to the visual in the background, to the video. And if I'm going to the motion avatar, then you see that it's actually drawing the lights in the avatar. So whatever I do in the avatar, this is actually what makes the avatar brighter in some spots, like relative to where I have my mouse position. Next thing is in the menu, obviously you have these little mountains and the lights that are changing and how bright the menu icons are, the 3D menu icons. In this scene, you would be able to make a little disco. So depending on where your mouse is, you would basically light up the particles here. And in the next scene, this is also dynamically working for the perspective. So if we are down here and everything is dark, can you show the sky a little bit? So if I put my mouse here, you would actually see that if there are particles in the background, then you would actually see that it's enhancing the brightness of these particles there. And in the next scene, this is something I found quite interesting because this was also reacting to sound and to the motion. And I chose to basically say if you put your mouse there, then the cubes wouldn't go up, they would go down. So if everybody would spread out through the whole room, then all the cubes would be down and nothing would be moving. If I go to a later stage in that scene, you can actually see that it also works in 3D. So depending on where you put your mouse, you could basically push the cubes down. And this would basically follow you around. But it was hard to come up with ideas because it's always, you always have like this switch between 2D and 3D basically. In this second to last scene, it was basically just like brightness values on the cubes. So when I'm in the corner of these cubes, I think it only shows up, it only shows up if you're looking to the right. And then you can see that you get like only in one corner of these cubes, you get like this little sheen, glow thing going on. And then in the last scene, we basically switch that off. And this is also why in the last scene, you don't have any trail anymore. So that we wanted to inform the people, now you don't have any action. You don't have any interaction on the screen anymore, but you still can throw emoticons if you want to. And just to finish it off, it's in the very first scene where we basically have like the onboarding scene. There you see that the interaction is actually making this background a little bit brighter. And if you go over the avatar with your mouse, which is a little bit hard to see right now, if I restart the scene, you should be able to see it a little better. If you go over the avatar with your mouse, then you're actually displacing the avatar a little bit. So that was your interaction in this scene. Yeah. So that's basically that.
So I guess like one of the biggest decisions was that we go for streaming instead of rendering on the phone or on the computer. And yeah, I think that's something I would be interested to think about for the like next stages. Like, is it something that we could like completely replace Unity, or we could render output Unity WebGL and deploy it on the browser, or we do something else, or we could do hybrid, something that we overlay on top of the streaming, and still. But I think the question is that is it recognizable, the interaction from the audience to the what you see on the browser? We can go like really far with technical parts, but it has to be always, the interaction has to be always clear.
Yeah. I think that is a very good point. Like the idea of going into WebGL could be very interesting, but I see challenges there. First of all, you would always have to think about like what is your output machines. Like the problem is if you want my mother to join the stream, for example, she only owns, because she doesn't need another one, she only owns a Aldi €150 laptop, and it's fine for her. But it would basically not be able to run like super sophisticated WebGL stuff. So we would have to put a lot of work in to make it visually interesting, and still like visually wowing in a way, or like maybe even scalable, so that the WebGL experience basically checks by itself, like what device am I running on, like how hefty can I do the visuals, because this is something that I don't want to give to the audience. Basically, this is a choice that I don't want to give to the audience, because everybody will always say, I want the highest quality settings, but everybody expects those settings to also work for them. So this is like a discussion that I'm still having in my head when thinking about this WebGL stuff. I think you can do amazing stuff in WebGL, and it's developing quickly, but it's like almost double the work, because you have to make it nice looking even on lower tier devices, and you have to make it scalable, and it's super hard to actually wow people, because you're going back 10 years visually, and like people expect different things, like expect different visuals right now. You won't be easily able to get Unreal Engine fidelity in the browser just yet without a lot of work.
Yeah. And I think there's also like trade-off of like how much like you want to personalize the visuals. For example, if it's WebGL, it can be, the mouse cursor triggers something and you don't see other people's mouse cursor, for example. That's possible with WebGL. With streaming, we have to always use everyone's data, otherwise it doesn't make sense. And this is, I think it's good and bad. If it's personalized, you see more direct interaction. Okay, I move the cursor and I'm not distracted by other 100 mouse cursors. But at the same time, for the performer, because Ine was watching it, well, not always watching, but there was a screen like projected on the wall, so she could see what's happening, what is the view that everyone's watching. So that's kind of a good way to connect as a overall audience. Maybe it's kind of democratic, but it's as a whole with a performer.
Yeah. There's also a different layer to that. That is the conscious choice that we wanted the audience to realize. That was the most important thing. We wanted the audience to realize that everything that we did was live. And one big part of that was that we showed Ine talking to the people in connection like to the visual. And we also wanted to show the interaction of the other audience members. Like this democratic part actually made it interesting. And a way of thinking about performances differently is like, for example, if you think about multiplayer games, and then if you show the other players and the other observers in the space, that is like a big thing. But again, like this would be something that we would have to investigate and see, like how much do we actually show? Like, do we show them as ghosts or do we show them as other avatars? But then the problem is, this is something that I noticed in like Mozilla Hub's performances that we did. People tend to only think about themselves. So in the virtual environment, they are not always aware of what their own action means to other users. We also observed that in this performance, like some people were just moving their mouse around wildly the whole performance, because basically the wording maybe was misleading, because it was always saying like move your mouse on screen, move your mouse on screen. But if you constantly do that, it's just annoying to everybody else because you're obstructing the performance for somebody else. So there's like a lot of stuff that we could research also in this direction, like how much do we actually want interaction of the users. Like in this performance, we try to go as far and wide as we could, but it's also super interesting to look at what you want to restrict and when you don't want to show everything. Right now we show everything all the time. The only thing that we take away is like sometimes you cannot throw emoticons because we felt like you shouldn't be able to constantly spam. And in the very last scene, we also chose to take away the option of actually interacting with your mouse to make it more relaxed and like to cool it down. But this is an interesting thing, and it's like there's a lot of things. Like if you think about harassment in VR chats and like people going into each other's different spaces, and like for example Facebook with the metaverse, what they're even talking about right now is that they have like these safe bubbles around their avatars, so you cannot go into somebody else's private space and sexually harass them. So you would immediately have to think about all these things, which is also a reason why we basically chose this setup here with Empty Minds right now, where we made it more abstract but safer and easier to control for us, and to still research a lot of the stuff.
Right. For example, you cannot type anything into the stream. Like
Yeah.
It's just mouse cursor.
Yeah. That was very interesting thing. Like that for a long while we were thinking that we were even giving chatting options to the people, but then we were discussing like how would we even display that? Like would we display that in the UI or would we display that in Unity? And the interesting thing that would come up was like how many letters would you give them? And what if you have a troll in there that is all of a sudden typing hate speech? Like what would you even do? Like would you try to throw them out? Like I think the backups, the system is set up in such a way that we could have even only allowed like logged in players, so that we were able to disable players who were misusing the system. But in the end, we just said like, okay, let's not use text at all and only use the mouse and the emoticons interactions. A few more minutes, I would round off with one last question, because the thing that I was really thinking about deeply is there is a big difference if you want to make a production and you want to produce like a generalized system, or if you want to produce a performance. In this case, because in this case, everything that we did is super focused on the fact that we want to produce a performance in the end. The idea was never that we would say this is a system that we can reuse in many different ways. The interesting part that turned out was that we now have a system that we can reuse in many different ways, and that we can still keep on working with. We could now use, for example, the whole production preview and this whole system that allows us to track like motion of the mouse and emoticons. We can use that now and create a different performance. But the idea was basically to create this one performance. And I think like if we would have gone into this realm of developing actually like a 3D environment thing, or a WebGL environment where people can interact with, that would have been a more general development. But I'm always afraid of like going into this super generalized thing, because then the performance itself becomes weaker. And for me, it was always important to also focus on a nice performative visual output at the end. And there's like a little discrepancy there.
doing like making generalized tool or
Yeah.
performance specific.
Yeah. And we had to do both at the same time for this performance. So there was no tool there. We had to create everything from scratch. And now we have at least a framework of something that we could use for a different performance. But interestingly, now we are at the point where we would actually, like Naoto said before, we would actually move on and say, okay, what now? Let's now, with all the knowledge that we gathered in this thing, move into development of like a generalized system of do something in WebGL. Like how can we make it like a modular input system? Like think about, for example, whatever motion capture system you have, you can feed it in there. Whatever audio data you have, you can feed it in there. Like how do you stream that data to the client? Do you do the analyzation of the audio? Do you do it on client side or do you do it on the server side? What do you actually stream to the clients? And this, like with the background knowledge that we have right now, and with this, with the knowledge that what we can do, I think restarting a project now and doing something would be amazing, and then building on top of that.
You see. Yeah, I mean, to me, I think it really comes down to like what we want to show, and if it's something that it's necessary to use the user input and does something in Unity, or sending cues from one to another, or using mouse movement, then definitely this is like we have something solid. And is it something that we want to add something to it, or is it like other kind of interaction we want to explore? And if it's something else, like some other kind of interaction, then maybe we have to build something else, or we could do something hybrid. But it really depends on. Yeah, I'm more like goal-oriented person, so like what kind of performance, or what. It doesn't have to be performance, actually. It can be, like for example, you could use the same thing for a lecture, like you can clap. I don't know if it's interesting or not, but so I think it's also about like what we want to create with this. Yeah.
So thank you. This was our little behind the scenes of Empty Minds, the technical walkthrough of whatever we did. And I hope you learned something. We hope you can see and experience Empty Minds at some point in the future. For us, it was definitely a super interesting process, working with all these different partners, bringing everything together. And we definitely hope to do it again. And see you soon.
And if you have any questions, write to us, and we can hopefully answer the questions.
Yeah.